Hello guys, this is Christine and today we will get some more help for organic chemistry. Today we will talk about Zaitsev and Hofmann products in E2 reaction. So first we gotta understand what is Zaitsev product, what is Hofmann product, and also we gotta know when each product is favored. So first we gotta understand what is the stability of an alkene. So the more substituted an alkene, the more stable it is. So the more substituted, the more stable. So look at this case. We have the tetra substituted. So we have this is tetra substituted. And remember the substituted is mean that anything but not hydrogen. This can be fluoride, or they can be CF3, or this can be alkyl group, or this can be isopropyl group, anything but not hydrogen. Then this is called tetra substituted. Why do we call it tetra substituted? So remember, tetra is mean 4. So we have 1, 2, 3, and 4. 4 branches go from the double bond. So we call this is the tetra substituted alkene. So the tetra substituted will be more stable than dry substituted and more stable than for bisubstituted. But in the case of bisubstituted, we gotta distinguish between trans and cis. Trans is more stable than cis. Why? Because in trans, we have the two branches pointing the opposite way, so they not interfere with each other. There's no steric hydrogens and no steric interaction. That's why it is more stable, because they stay away from each other. They're not branching and fighting with each other. They stay away from each other. So this is more stable, and this is less stable because this and this go to the same side of the alkene, go to the same side of the double bond. That's why it's the less stable, because these two branches often meet each other and they interact with each other. They have steric interaction. That's why this is less stable. And then of course bisubstituted is more stable than monosubstituted. There's only one branch coming from the double bond. This is monosubstituted. And of course it is more substituted than having nothing coming out of it. So this is C2H4, so it is more stable than this, right? So this is the stability chain. You can take a look at that and taking notes. So tetra substituted is more stable than tri-substituted, and it's more stable than bisubstituted. In bisubstituted, we have trans is more stable than cis, and then the bisubstituted is more stable than monosubstituted and more stable than C2H4. Alright, so let's talk about Zaitsev product. So what is Zaitsev product? Zaitsev product, or we say that it's the more stable product. It means that it's more substituted. And also we have another term, it is the thermodynamic product. It means thermodynamic product is mean that it's forming slowly, but it's more stable and it lower in energy. So if the teacher gives you a question and ask you, what product did it form? Did it form Zaitsev product? Or in other ways, you can ask pointing out which one is the more stable product, or pointing out which one is a thermodynamic product, or more lower energy product, more stable product. You have to know it's the same thing. It's the Zaitsev product. And also Hofmann product. Hofmann product is less stable product, so it will be less substituted. And this is forming really fast. It is a kinetic product. It's forming really fast and it's kinetic product. So if the teacher asks you, what is the Hofmann product? Draw the structure of the Hofmann product. Or draw the structure of the less stable product, or draw the structure of kinetic product, or the product forming faster. Then you all have to know this is all the same thing. It means Hofmann product. So when did the Zaitsev product form? The Zaitsev product form, all of the Zaitsev and Hofmann product is forming in E2 reaction, elimination reaction 2. So Zaitsev product form when we have a small and really strong base. So these are some examples. For example, OH, Ca3O, or ethyl group. So anytime you see a lone pair of electrons right next to an oxygen, and it does not have a lot of, it's not branching, it's not a bulky hydrocarbon, then this is a strong, small base, right? So when does Hofmann product form? Hofmann product form when in E2 reaction, when there's a big, bulky, and strong base. So the example can be DBN, DBU, or it can be TBUOK, Toprudo K, right? So Toprudo K is actually in this form. So why is it bulky? We can have the really branched here. It's really branched, really steric hydrogen. So it always form the less stable product, but a faster, less substituted Hofmann product. So let's go through some examples to understand it better. So for example, if I have this reaction and ask you guys to give me the structure of the major product, give me the structure of the major product. So first I have to identify if I have a small base or a big base. So NaOH is a small base. NaOH is a small base. It's actually OH right here is a small and strong base. So for sure, it gives me Zaitsev product. Zaitsev product is mean that a more substituted product or more stable product. So if I look at this point, I have Br is right here. So my double bond either can be formed on this side or either can be formed on this side. So let's take a look. If I have my double bond forming this side, I will get a I will get a bi substituted product, right? If I cover Br, so if I have, imagine that if you have a double bond forming right there, then right now you will have a bi substituted product. This is bi substituted product. But if I have double bond forming right here, then I will have a tri-substituted product. So the tri-substituted product is more substituted and is more stable. So the tri-substituted product is actually the Zaitsev product. So, excuse me. So my Zaitsev product will be formed, and for sure I know it gives me Zaitsev product. But also you want to consider that trans is more stable than cis. So in this case, if I have my double bond forming right here to make a tri-substitute product, I also want to flip this down. Why do I want to flip this down? Because these are really bulky and these are really bulky. The bulky part want to stay away from each other as it can. This is a trans product of the tri-substitute product. So this is the most stable one. You can also form the tri-substituted product, but you have a cis form like this. But this one is not as stable because this has steric hydrogens right here. So this one is not as stable. This is a minor product. So when you have an alkene, you also want to consider if you're going to form trans or cis product. Trans will always favor more than cis product. Alright, let's move to the next example. So for next example, I will look at NaOH. NaOH is a strong and small base. So I know I will form Zaitsev product. So if I look at here, my bromide is right here. So either my double bond can form right here, or it can form right here around my bromide, right? So if it form right here, I will have a mono substituted. But if it formed right here, I will have a tri-substituted. So tri-substituted is always more stable than mono substituted. For sure, I will, with a small and strong base, I will have a tri-substituted, which is a more stable and a Zaitsev product. And in this case, you don't have a cis or a trans, because this and this, the methyl group and methyl group are the same. There's no chiral center here. There's no different here. So if you flip this, or if you flipped it, they are the same. They are the same thing. So there's no cis and trans here. So we don't have to consider that. So this is the only product, major product they're forming. So let's look at this. So now, in this case, I have a Berkey base. I have a really Berkey base in here. So it will favor Hofmann product. This means the less stable product. Because it's so Berkey that it make this product cannot form in here. So either if I have bromine here, it can either form from here or from here. If it's formed from here, I have a tri substituted. But if it formed from here, I have a mono substituted. And remember, the DBN is a Berkey base. It's one of favor the less substituted product, less stable product. So is most likely will form the double bond form right here, which is a mono substituted. But also you want to understand the reason why. So my product will give us like this. This is my product. Because this is mono substituted, it's less stable. Since this is a Berkey base. So because this is a Berkey base, it doesn't want to attack right here. Because if it attack right here, if my double bond forming right here, is mean that this hydrogen is participating in the reaction. But because since this is so Berkey and so big, it doesn't want to take the hydrogen from here, because here is already really hydrogens, really steric hydrogens already. They cannot come in there because it's so big. So they can take the hydrogen, but they can take the hydrogen from here really easy. Just take it from here. There's no steric hydrogens. It can easily take it because it's so big. So this is my Hofmann product. When there's a Berkey base, there's a Hofmann product, less stable product. So let's look at this. This one, CF3ONA, is a small and a strong base. So this will give me a Zaitsev product. So if I have a Zaitsev product, then this will give me a Zaitsev product. However, if we look at this, my bromine is right here. So there's only one double bond. Only one way can form double bond is right here. There's no other way. So in here, I don't have Zaitsev or I don't have Hofmann product. I only have one way to form my product. So this is the only product that formed. Then there's no distinguish between Zaitsev or Hofmann. Okay, so that's it for this video. It's about Hofmann and Zaitsev product. So I will put this right here, so maybe you guys can take a note or anything that you guys miss. And I will make another video talking about stereospecific products in E2 reaction. Make sure that you can check it out and understand the concept better. Thank you for watching the video and good luck with organic chemistry.